Algorithmic flowchart in sequencing. Flowcharts are visual representations that use various shapes and arrows to depict the steps and flow of execution in an algorithm. Each shape represents a specific action or decision, and the arrows indicate the sequence in which the steps are followed. Let's use a flowchart to represent the algorithm for finding the factorial of a given number. Now, let's represent the above algorithm using a flowchart. In the flowchart, the oval shape represents the start and end point of the algorithm. The rectangle represents actions or steps, and the diamonds represent decision points not present in the algorithm. The arrows show the flow of execution from one step to another. Flowcharts are a powerful tool for visually representing algorithms, making them easier to understand and follow. They are commonly used in programming, software development, and problem-solving processes. Example: flowchart to calculate the area of a square. This flowchart represents a simple algorithm for calculating the area of a square based on the input side length, A. Flowcharts are an effective way to visually represent the sequence of steps and decisions in an algorithm, making it easier to understand and follow the logic of the program. Pseudocode. Pseudocode is a method of representing an algorithm using human-readable, informal language that closely resembles the structure of a programming language. It is used to outline the logic and steps of an algorithm before translating it into a specific programming language like Python. Pseudocode is not meant to be executed by a computer but serve as a guide for developers to understand and design their algorithms. In Python, pseudocode can closely resemble the actual code and use Python-like syntax, but it is not necessary to adhere strictly to Python syntax rules. Here's an example of pseudocode for finding the factorial of a positive integer num. In this pseudocode, we outline the steps to calculate the factorial of a positive integer num. It starts by checking if num is 0 or 1, as the factorial of these numbers is 1. If not, it initializes a variable fact to 1 and uses a loop to calculate the factorial by multiplying fact with each number from 0 to num. Remember that pseudocode is more like a human-readable representation of the algorithm, and you would need to convert it into actual Python code to execute it on a computer. The pseudocode serves as a blueprint for writing the Python code, making it easier to understand the logic and steps involved in the algorithm.